Hi, it's Rob. Welcome to the next video in the DevOps on AWS playlist, where we'll build a code pipeline using CloudFormation. If you watched the prior videos in the playlist, you'll recall we created a code pipeline consisting of a CodeCommit repo, CodeBuild project, a CodeDeploy app, and a code pipeline using the AWS console. In this video, we'll provision these products using CloudFormation templates and execute the commands to build them in the AWS CLI. Before we get started, I want to mention that since the focus of this video is on provisioning the pipeline and not an intro to CloudFormation, having some hands-on experience working with CloudFormation templates will be helpful in following along. Also, the app we'll be deploying from the pipeline is a simple SpringBoot app, which I used in the prior videos in the playlist. I won't be walking through the code for the app in this video, but I'll provide a link in the description below to a prior video in which I gave a brief overview of the code if you're interested. Finally, the AppServer infrastructure, such as the security groups, ingress rules, and EC2 instances used to deploy to in this video, was already provisioned using the AWS CLI. I'll also provide a link to a video in the description below which covers this. Okay, with all that out of the way, let's start building. First, I've created an IAM user named CCDeveloper with administrator access and generated access keys for the user, which I use to configure a local profile. I also created Git credentials for the user so I can interact with the CodeCommit repo we'll create next. Now, jumping into the code and looking at our first CloudFormation template for a CodeCommit repo, we see in the parameters section, I have one parameter named repo name, which is a type string and a default of an empty string. Here I'm creating one resource, which is an AWS CodeCommit repository with the name of CCDemo app repo, and it has a single property of repository name, which is a reference to the repo name parameter declared above. In the output section, I have an output for the demo app repo name, which will be obtained by getting the name attribute from the CCDemo app repo resource, and then I'm exporting the name so I could import it in other templates in the stack. I also have an output for the demo app HTTP clone URL, which I'm exporting as well. Now, instead of jumping into the CloudFormation console and uploading this template, I'll be executing CloudFormation API commands from the AWS CLI. These commands are in the README file in the GitHub repository linked in the description below. Now, the first command I'll execute is AWS CloudFormation validate template, pointing to the template body of file 1 underscore CodeCommit YAML, which is in the current working folder. So I'll copy the command and jump into a terminal and execute the command. And this output tells us that our template is valid. Now, I'll go back to the code, and the next command I want to execute is a CloudFormation create stack, giving it a stack name of CCDemo app repo. The template body will come from the 1 underscore CodeCommit YAML file we just validated, and I'm passing a parameter file in the params folder with the name of 1 underscore CodeCommit params.json. So let's jump into the params folder and open up the CodeCommit params file. And we see this is an array with one object literal. The object literal has two properties, a parameter key with a value of repo name and a parameter value of CCDemo app repo. This parameter key of repo name matches the parameter name in the CloudFormation template. So when I execute the create stack command, passing it the template and the parameter file, the value of CCDemo app repo will be the value of the repo name parameter. So let's copy the command, jump into a terminal, and execute it. Here we're given a stack ID. Then let's go back to the README and grab the next command, which is a CloudFormation describe stack, passing it the stack name of CCDemo app repo, which is the stack name we just created in the create stack command. And executing this command will give us details of our stacks. However, what I'm really interested in is the stack's status. So I'll execute the same command, this time grepping for stack status. And here we see our stack is in create complete status. So if we jump into the AWS CodeCommit console, here we see our demo app repo. And if we jump into CloudFormation, here we see our CC demo app repo stack. And if I go into outputs, we'll see the CC demo app repo name and the HTTP clone URL. So I'll go ahead and copy the clone URL, then jump into a new terminal and execute a git clone, passing it the clone URL. Here it's prompting me for my git user credential, so I'll paste that in, and then the password. Then cd into the repo, then copy the files from my backup folder into the new repo. Then jump back in the terminal and add, commit, and push these files to the remote CodeCommit repo. And now if you jump back into the CodeCommit console and go into our repo, we see our files. Okay, with the CodeCommit repo in place and our code pushed to it, we can move on and provision the rest of the code pipeline. First, however, we'll provision an S3 bucket, which the pipeline will use to store its artifacts. And for that, I have this CloudFormation template named s3artifactbucket.yaml. It has one parameter named bucket name and creates one resource, which is an AWS S3 bucket named S3 bucket with properties for bucket name, which is a reference to the bucket name parameter, and sets versioning to be enabled. It has one output named CC demo app artifact bucket. Its value is a reference to the bucket name, and it's exported as CC demo app artifact bucket. So I'll grab the CLI command to validate the template and jump into the terminal. And this looks good. So now I'll grab the command to create the stack, giving it a name of CC demo app bucket, pointing to the template body of the file we just validated, and passing a parameter file of S3 artifact bucket name. So if we go into params and open the S3 artifact bucket name params file, we see it has a param key of bucket name, which again is the parameter name in the CloudFormation template, and a bucket name. So I'll copy the command, go back to the terminal, and execute it. So there's our stack ID. Now I'll copy the command to grep for the status, and we see the stack is in create complete status. So if we jump into CloudFormation, here we see our CC demo app bucket, and if we go into outputs, we see the CC demo app artifact bucket key with the value of the bucket name and its export name. And jumping into S3, we see our bucket. Okay, the next step is to provision the CodeBuild project. And for that, I have the CodeBuild YAML file. This file has one parameter named build project name, whose value comes from the CodeBuild params.json file. The parameter key matches the parameter name, and its value is CC demo app CodeBuild project. This template creates two resources. The first is an AWS CodeBuild project, whose properties have a name which references the build project name parameter, a service role, which is the CC demo app CodeBuild roles ARN. And if we scroll down, we'll see the second resource, which is an AWS IAM role named CC demo app CodeBuild role. This role's properties has an assume role document policy whose statement allows the principal service of CodeBuild to perform the STS assume role action. and its policies has a policy document with statements to allow CodeCommit to perform a git pull on the resource, which is our CC demo app repos value imported from the CodeCommit template's export value. The policy document statement also allows creations of log groups, log streams, and put log events, and allows S3 actions on the artifact bucket's object, where the artifact bucket is the imported value of the exported bucket name from the S3 artifact bucket template, as well as a reference to the artifact bucket itself. In the output section, we have an output for the CC demo app CodeBuild role, whose value will be a reference to the CodeBuild role and exported as CC demo app CodeBuild role, and an output for the CodeBuild project, which is a reference to the CodeBuild project in the resources section above, and is exported as CC demo app CodeBuild project. Scrolling back up to the AWS CodeBuild project resource, the next property is the artifacts property, which is of type S3 and is a reference to the build project name passed in as a parameter. And the location of the S3 bucket is the value which is imported, named CC demo app artifact bucket, which was exported in the S3 artifact bucket template. The environment is a Linux container with the compute type of build general 1 small and has a Java OpenJDK 8 image. The source location for the CodeBuild project will be imported from the CC demo app repo name and is of type CodeCommit. So let's grab the command to validate the template, jump into the terminal, and this looks good. And now we'll grab the create stack command, which points to the template body for the CodeBuild YAML file and the params for the CodeBuild params.json. In this case, since we're provisioning an IAM role, we need to pass the capabilities of capability IAM and capability named IAM. So there's our stack ID, and grepping for stack status shows that the stack is still in create in progress status. So let's jump into CloudFormation, go into stacks, refresh, and here's our CC demo CodeBuild project, which is now in create complete status. And going into outputs, we see the outputs for the CodeBuild project and the CodeBuild role. And if we jump into the CodeBuild console, we see our CC demo app CodeBuild project. Okay, so now we have our CodeCommit repo, our S3 artifact bucket, and our CodeBuild project provisioned, so we can move on to our CodeDeploy application. In the CodeDeploy YAML file, we see we have one parameter named CodeDeploy App name, which will be obtained from the CodeDeploy params.json file and has a value of CC demo app CodeDeploy app. This CloudFormation template has 4 resources. The first is an AWS CodeDeploy application with properties for application name, which is a reference to the CodeDeploy app name parameter, and a compute platform of server. There's a CodeDeploy dev deployment group and a CodeDeploy prod deployment group. Looking at the dev deployment group, we see it's an AWS CodeDeploy deployment group type. Its application name is a reference to the CodeDeploy application resource created above. Its EC2 tag filters are of key and value type, where the key is environment and the value is dev. And if we jump into the EC2 console of the pre-provisioned servers and look at the tags for the instances, here we see our 4 app servers that are currently running. This one has an environment tag of prod. The second is also a prod server, and the third is a dev server, as well as the fourth. Now, getting back to our deployment group resource, we see a service role ARN property, which is a value of getting the attribute of ARN from the CodeDeploy service role resource. Looking at that resource, We see its type is an IAM role. The role name property is CodeDeploy service role, and it has an assume role policy document statement, which allows the service principal of CodeDeploy to perform the STS assume role action. The policies has a policy document statement, which allows EC2, tag, SNS, and CloudWatch actions. And finally, the deployment group has a deployment group name of Dev Deployment Group. The CodeDeploy Prod Deployment Group resource is similar to the Dev Deployment Group, the difference being that the environment key's value is prod, and the deployment group name is Prod Deployment Group. Finally, scrolling down to the output section, we see outputs for the CodeDeploy service role, which will be exported, the CodeDeploy application, which will be exported, and outputs with exports for the CodeDeploy Dev Deployment Group and CodeDeploy Prod Deployment Groups. So let's grab the CLI command to validate the template, jump into the terminal, and that looks good. So now we'll grab the command to create the stack, noting that once again we're passing capabilities for capability IAM and capability named IAM because we're creating IAM roles. So there's our stack ID, and the stack is still create in progress status. So let's jump into the CloudFormation console, and now we see our CC demo code deploy stack is in create complete status. And if we look at the outputs, we'll see our exported output names as expected. And jumping into CodeDeploy, we see our CC demo app CodeDeploy App application with the dev deployment group and prod deployment group. So that leaves us with one more resource to provision, which is the code pipeline itself. And looking at the YAML file for the code pipeline template, we'll see that there is one parameter named email, yet it's commented out. This could be used to provision an SNS topic resource, passing the value of the email address to send the SNS notification to. In this case, I'm not going to use the parameter. So when I execute the CloudFormation create stack, I'll pass the stack name, the template body, and the capabilities, but in this case, I won't pass the parameter file. Looking further down in the resources section of the CloudFormation template, we'll see a resource for a code pipeline role and the code pipeline. The code pipeline role is an IAM role with an assume role policy document allowing code pipeline to perform the STS assume role action. The policies has a policy document which will allow S3 actions on the resource for the imported S3 bucket and its objects. There's also an effect to allow publish to SNS, which in this case we probably could comment out, as well as allows CodeCommit actions on the imported value for the CC demo app repo name of our CodeCommit repo. In addition, there's an allow for CodeBuild, start build, and batch get build actions on our imported value for the CC demo app CodeBuild project. And finally, there's an allow effect for CodeDeploy actions. Looking at the code pipeline resource, we'll see this is an AWS CodePipeline pipeline type. The role ARN is the ARN attribute of the code pipeline role resource created above, and this pipeline has 5 stages. The first is a source stage with an action type ID category of source, and the provider is CodeCommit. The source stage creates an output artifact with a name of application output, which will be the input to the build stage. The configuration for the source stage is the repository name, which is imported from the CC demo app repo name, and we're targeting the main branch. The build stage, again, takes an input artifact of the application output stage. Its action type ID category is build with a provider of CodeBuild, and it produces an output artifact of CodeBuild artifact. the configurations project name is imported from the CC Demo App CodeBuild project. The next stage is deploy to dev, which takes an input artifact of the CodeBuild artifact output from the build stage. Its action type ID category is deploy with the provider of CodeDeploy, and its configurations application name is imported from the CodeDeploy application export, and the deployment group name is imported from the CodeDeploy dev deployment group export. Following the deploy to dev stage is the manual approval stage. This action type ID category is approval and the provider is manual. And after the manual approval step is complete, the final stage is to deploy to prod. The input artifact for deploy to prod is again the CodeBuild artifact. The category is deploy with the provider of CodeDeploy, and for the configuration, the application name is again the imported CodeDeploy application, and the deployment group name is the imported CodeDeploy prod deployment group. And finally, the artifact store is S3, and the location is the imported CC Demo App artifact bucket, which was exported in the S3 artifact bucket template. Okay, so let's grab the AWS CLI command to validate the template and jump into the terminal and execute it. And this looks good. So I'll go ahead and grab the command to create the stack and passing capabilities. And there's our stack ID. So let's jump into CloudFormation. And here's our CC demo code pipeline, which is in create in progress status. Now the pipeline's complete, so let's jump into the AWS CodePipeline console. And here we see our pipeline, which is in progress. And we see the source stage has succeeded, and now the build is in progress. Okay, now the build is complete, and it's moved on to the deploy to dev stage. And now the deploy to dev stage is complete, and it's moved on to the manual approval. However, before we approve, let's jump back into the EC2 console. And here we have one of our dev servers selected. So let's grab the IP address, jump into a new tab, and hit the demo app route on port 8080. And we see version 1 of our application deployed. So let's go back to CodePipeline, and we'll review for the manual approval and approve. And with the manual approval step complete, it's moved on to deploy to prod. Okay, and with deploy to prod complete, let's jump back over into EC2. We'll grab the IP for one of our prod servers and jump into a tab and hit the route on 8080. And we see version 1 of our app has also been deployed to our prod servers. All right, so our pipeline is in pretty good shape right now, but we have one more test to do. So we'll jump back into the code, and in the application properties file for our application, I'll change v1 to v2, save it, then jump into a terminal and push this to CodeCommit. Now let's jump back into the CodePipeline console, and shortly we should see our source stage in progress. Okay, so the source stage jumped right to succeeded, and now the build stage is in progress. And with the build complete, it's moved on to the deploy to dev stage. And with the dev deployment complete, it's moved on to the manual approval stage. But before we approve, let's jump into the browser tab again and refresh. and now we see version 2 of our app deployed. So let's go back to the pipeline. We'll review and approve. And now the pipeline has moved on to deploy to prod. And with prod deployment complete, if we jump into the browser tab and refresh, we see our app is updated in prod as well. Okay, with the final test of our code pipeline resources complete, we could jump back into CloudFormation, and what we'll do now is delete the stacks. But again, instead of doing this in the console, let's jump back into our README file. And here we see CloudFormation delete stack commands passing the stack name for each of the stacks we created in our pipeline. So I'll copy these one by one, jump into a terminal, and execute them. And now if we jump back into CloudFormation, we'll see that our code pipeline stack has already been deleted, and now the CodeDeploy stack is delete in progress. And with the exception of the demo app bucket, all our stacks have been deleted. And this delete failed because the bucket isn't empty. So what you could do now, if you're interested, is go into the S3 bucket and delete the objects, and then come back and delete the stack. So that concludes this demo on building an AWS code pipeline using CloudFormation and executing the commands via the AWS CLI. If you found it interesting, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.